Hi, this is your favorite tutor Yomi Omorewa. So we're looking at homogeneous differential equation. Already I've done a particular example on it, and I want to do another example so that you have a well-grounded understanding in the homogeneous differential equation. And in case you're new to my page or channel, it's important you check others that I've done on separable variable, on integrating factor, and then I did something on Laplace transform. Check all of those things out, and then where you have question, you're free to ask your question. So we have this question quickly. Suppose you're given this y prime equal xy s square and y square. Suppose this is what you're given. Now we know that this can also be expressed as this. So it's homogeneous because you can see, you can decide to put it here. So it's equal. So you can see that, right? So from here, you remember, this is where we begin from. And this is, let's say, equation 1. So you differentiate dy so that you have your x dv using product rule, and then you have your v dx. So let's call that equation 2. So you go back to your original equation, you have x dy dx, that's x this over s squared this. So what do you do now quickly? Where you see y, you put what? Vx. So Vx. And then where you see y again, you put what? Vx. And then here you square it. So we have dy dx. So you have s square v over s square v square and s square. So you have this now. To make it simplify, let's remove the x. That's when you will know that the question you are given is homogeneous. You can easily cancel out. That's when you will know. So cancel. It's a must. So you should be able to cancel out. So you have that. And that gives you dy dx equals to v over 1 what? V square. So recall equation 2. Okay, before we recall, let's cross multiply. So we have dy recall your equation 2. So recall equation 2. So we have equation 2, that's x dv v dx, and then 1 v square equals to v this. So that you can open the bracket, you have x dv, and then you can have these two. When you multiply this by the, you have x, you have v square dv, then this times this, you have plus v dx, then this times this, v appear 3 times, and then dx, then v dx. So from here, I know that v dx is common. Look at it here. So we have x dv equals to x v square. Remember, this times this times this times this times this. So there's no error at all. So we have x this, and then we have v dx. Let this come inside, and then this can even go outside. Yes, it can. So this one go, this one go. So we have x dv equals to fv squared dv equals to V. Yes, any question to this point? In case you have any question, you can ask. So what's the next thing? I'm looking at something very common here. I think X is common. dV is also common. So you have one V squared. Yes. And also seeing this. Okay, so from here we can apply separable variable. So you can apply separable variable here. And to apply separable variable here is also simple. Take this down here, take this one down here. So we have one, and then we have 1 over x dx. So what's the next thing? Integrate. So we have this. So if we want to integrate that, so we have 1 you can separate it. So let's integrate this. I'll just be very fast. Take it up. Okay. Let me take it off so that it doesn't look like I'm jumping a step. I'm trying to make things very clear, and this you can cut this one out so it becomes the when you share it, when you divide that, you have that. So for this, integrate this, you have 1 over 2 v squared. When you integrate this, you have ln v, and then this is ln x plus c. So this is the same thing as 1 over v squared. So this is 2, please. 2. And this is ln v ln x plus c. So recall from equation 2, y is vx. So therefore, v is this over this. So we have that. So in that case, anywhere I see v, I'm going to put what? V over x. So come here. You have minus, so this is v over x all square. So we have this ln x plus c. So this is what you have. So in this case, you remember that from the law of log, if you have ln a minus ln b, it is ln a b from law of log. So I can say minus 1 over 2. So, okay, sorry, this is minus ln y minus ln x equals to this plus c. Yes. So we have so this way, if you open the bracket, you have ln y plus ln x, this plus c. So if you look at ln x here, if you take in ln x here, it will cancel out. So you have 2 equals to this ln y, right? lane Y, and you'll be left with lane Y here. So if you take this one here, equals to, so let's say C. Yes, let's say C. So you have this, because this one will go here, and then when it goes here, you are left with C here. So you can do this. And these two can come here. My lane Y can also come to this way, can come this way rather. And when it comes this way, I can do something about it. So, and I can also do something about this, the one here. So, in whichever way, I can put the plus C at this other side. I can put the plus C at this other side of the equation too. So it depends on where I want to put the equation. So it depends. So if I'm not putting it here and I'm putting 0 here, I can come and put my constant somewhere here. So let me wipe the board. Now I can have my minus is equals to my lane Y. So I could decide to put my constant here. So it can be yes. So I could have it this way. So if I have it this way, what's the next thing I can do here? So I can apply exponential to both sides. So in mathematics, this one is the same thing as this, and it's the same thing as yes. So you have so from here, this is a constant, multiplied by this constant is a constant. So I could decide to now put my constant here. So that one will go. So I have this. And there's a law of this, that when you have something like this now, what happens? This is ordinary Y. So my final answer is Y CE 1/2. So this is what you have, okay? Remember the original question. This was the original question. Original question was Y prime equals to XY S square and this. And this is the final answer. Till I come your way again. Bye.